Yeah, good morning everyone once again. Yes, before understanding today's concepts, let's try to recollect it what we were understanding. Yeah, so in the last section, which we are looking about it, yeah, last two sections, if you go through that about EBS volumes, we are understanding. Yes, what are the different types of the volumes are available and what is the importance of the EBS and how do we attach or detach the EBS volumes to the EC2 instance. And how do we create a snapshots on the EBS volume and the snapshot how you can copy to that other regions, and after copying that how you can use that snapshot creating as an AMI, or you can create that with volume. Yeah, the snapshots with volumes and volume to the snapshot, but snapshot is the backup of the current state of the disk which we have that. And even that snapshot also we can define with the lifecycle management, that is taking the backups on the base of some interval. But during the restoring, so what are the latest restore point of the snapshot which we have, you can take it and you can restore it that in case the volume corrupted. Yeah, there are the points that we are trying to understand it. And finally we had that different types and snapshots and encryption option. Yes, one time if we do the encryption of the volume, and that volume, if you're going to creating that the snapshot automatically will be encrypted. And the snapshot, whenever you are transferring over the network to the other regions, yes, the data is the secured. And the snapshot which is having as a backup, yeah, the data on the snapshot is secured. And using that snapshot and what are the volume you are going to create it, that volume is also the encrypted. Yeah, data at rest is encrypted, all the data in the flight moving is encrypted, all snapshots are encrypted, all volumes created from the snapshot also encrypted. Yeah, encryption is one of kind of the security on the disk level. Yeah, that's options we are understanding. And finally, the difference between the EBS and instant store. Yeah, how to create EBS volume? Yes, we are practically working with that, but instant store is not that much importance, so very less scope that we use it. Only better IO performance we use it. Remaining all are disadvantages we have. What are the disadvantages? We should not say the disadvantages, but some management activities. So on the termination, the instant store is lost. That means you need to take care of it about backing about the data about ourselves. And you cannot resize the instance store once it is defined. So overall, EBS backed instances should fit most applications workloads. Yeah, that's we were concluding that, and then we were started understanding about what is the scalability and high availability. So scalability, we're talking the vertical scalability, horizontal scalability. Vertically, that is a scale up or scale down, and horizontal scalability, that is a scale out or scale in. So horizontal scalability that is applicable for non-distributed servers or services like middleware servers or the web server components. We can use it that horizontal scalability. Like example, EC2. On the EC2, if you are doing that web servers management or app servers management activities or any reporting services other than the backend. Backend don't go for the cache and especially database. The remaining services, we can use it horizontal scalability. You can add the more instances or you can decrease that. And vertical scalability. This is databases or cache system that can be applied, but we have some limitation on the hardware resource to use it, right? But this is going to use it active passive mechanism. And horizontal scalability is active mechanism. So all the instances you can make it active. And through the load balancer, you can route into that any one of that which is active. But vertical scalability, only one is active. but that one is failed, then the have the backup and passive mechanism. Passive one has to become that active. Yeah, vertical scalability, horizontal scalability, and understanding that high availability. Yes, there are the different components, but altogether we have this. The finally high availability is also the related to this. Yeah, finally, what are the solutions we have that on the EC2 instance for high availability and scalability is? Yes, EC2 point of view, horizontal scaling is auto scaling and with the load balancer. But this auto scaling in that group, what all the EC2 instances we are going to launch it? All the instances don't launch it in the same availability zone. Use it multi-availability zone. Yes, that is auto scaling group with multi-availability zone. That's we can say that horizontal scaling with the high availability. Even one data center lost it. Yes, you have that's another data center which is available. And even one instance got failed. Yes, you have another instance which is available. And the scaling is going to take care of that increase in that instances on the base of the current load. Yeah, so finally high availability we just talk it. So run, auto scaling group with the multi-availability zone and as well as define the load balancer with the multi-availability zone. That is the final conclusion, high availability and the scalability. Yeah, this was a concept which we are understanding and concluding in the last section. Are you clear about these points? Any queries, questions, please let me know before moving to the next section.
Clear, sir. What the doubt I asked in WhatsApp group also, that is also cleared.
Oh, okay, good. Yeah, yes, you were giving, you were sending us one message where.
Yes, sir. Yes, sir. Actually,
Okay.
I got the doubt because when I am creating template, that enabling public IP, enable,
Yes.
that is, initially I didn't enable that. That's why I didn't got web that script
IP address.
user data that
Okay.
I didn't get. But
Okay.
after that, after enabling that one, I got that.
Okay. Yes. Public IP address should be enabled.
Enabled. Yes.
That is in the VPCs anyway. I will talk it about it.
Okay.
But normally, if you're using the default, the subnets explicitly, that subnet level, some subnets are enabled with the public, but some subnets
Okay.
are not available with the public. Then you need to
Okay.
make sure if the instance if you'd like to access from the outside, enable explicitly on the base of the subnet which you are using.
Okay.
Yeah, that is, you will get it that concept in the networks, but for the timing. So whenever you select the subnet, so check it with that public IP address, is it enabled or not? If it is not enabled, but if you are going to use it at the public IP, then you need to make sure that you're enabling that. Okay. Is it that right? Clear, right?
What?
Is it clear that point?
Yes, sir. Clear.
Okay, cool. So how many of you are going through these lab guides? Yeah, IAM and EC2 launching. So far you can continue with that. So all those lab guides in this section. Initial users management and then the EC2 section which are trying to understand. AWS free tier account and browsing that AWS console, introduction to AWS IAM, organization and SSO. That's video related the lab
Sir,
guides.
sir, in this lab guide, lab guide and template is not there, sir.
Yeah, template not there. I have so launch wizard is there. But anyway, you will get it in the auto scaling group. Separately, I didn't
Okay.
give this lab guide.
Okay. Okay.
You will get it in the auto scaling group.
Okay. When I got the doubt, I searched in this lab guide also.
Okay. Fine.
Okay. Okay.
Yeah, so that's I didn't give that separately. Let me note that point. Yeah, launching EC2 instance for the Linux, Ubuntu, Windows. Yes, they're all like a different the lab guides. The working with the different types of instances and allocating that elastic IP, EIP. So that was, and then let's go to the second option. Yeah, EBS volume, ALB, ASG. Those lab guides are also available. Yeah, creating AMI from EC2 instance. Yeah, create an EC2 instance, create a new AMI using that EC2 instance, checking the new EC2 instance created with AMI and launching the EC2 instance created with AMI. Yes, AMI, EC2 to AMI, AMI to that EC2 launching. And this is about EBS volumes and snapshots. Yeah, launch the EC2 instance, create an Amazon EBS volume, attach and mount the volumes to EC2 instances, create and configure the file system within that. That is LSVLK and mounting options, and create a snapshot of the volume and restore Amazon EBS snapshot. That means creating the volume once again back and checking for that. Yeah, so these lab guides. So just follow that. Now let's move into that next concept and interesting, that is load balancing. So what is this load balancing? Yeah, as we're talking about it, horizontal scaling to handle the load. Suppose now initially we have this only two EC2 instances. Or okay, now so far we are working with only one EC2 instance, right? Only one EC2 instance. Launching the Apache service on it and accessing that directly through the EC2 instance URL. But can we say that is a high availability? No, that is not high availability. Even if that instance is lost it, then we'll be losing that the application. End user cannot access it. So as we are talking this in the high availability concepts, at least two EC2 instances required. That means two virtual machines required with the same application and service. But if I'm having the two EC2 instances, then two different URLs, right? Two different URLs. First EC2 instance, one URL with it, its public IP address with its port, and second EC2 instance with its public IP address and its port. Yeah, how do we handle that situation? So user, now you should not give the two the EC2 instance URLs, right? First access this URL, and if it is not working, use the second URL. No, we should not give it to that user like this. Multiple URLs has a number of servers. So between the user and to the backend, not backend, yes, that's middleware components or the web server components. We will be managing about the load balancers. So this load balancer is the first interface or first interaction with the user which receives the request, and it is going to checking about it, the backend services health monitoring, and if the health of these EC2 instances are the okay, then it routes this request, user requested hand over to that one of the EC2 instance. Then that EC2 instance processes the request and it gives the response back to the load balancer, and the load balancer returns back to the user. Yeah, load balancer, we can say this is as not only just load distribution as a name point of view, but it is going to, before load distribution, it is going to check the health of the instances also, whether it is reachable or not. If the health of this EC2 instance and the service health is also important, right? Service health. Suppose if I'm running on the EC2 instance 80 HTTP service, maybe EC2 instance is reachable, but 80 service is down. Then even if I route the request, EC2 cannot handle, right? 80 has to handle that, the service. So health checkups always not on the EC2 level, that is on the EC2 instance service level. That is important. Yeah, where that application is running on which service, if it is running on the Tomcat service, or if it is running on the HTTPD services, whatever the service you have, that service health checkup you need to define in the load balancer. And the load balancer is going to receive the request, and on the basis of this, the health, if the service health is okay, and if you have the multiple the services health is okay, then it is going to randomly with round robin, not randomly, round robin algorithm, it is going to use it. First user request to the first EC2 instance, second the request to that another instance, third user request to the third instance. Like this, randomly it is going to send the, not randomly, round robin, it is going to use that, and it is going to forward the request to the backend EC2 instance. That's about the load balancer concept. A load balancer, whenever we are understanding, we need to keep that 2 points in the mind whenever we are configuring the load balancer. So this load balancer, how you are going to give it to the user, this side configuration. That's we say that listener configuration. Listener, load balancer is going to listen in the requests. That's we say that listener. But once it has received the request on that URL, but it has to route to that the EC2 instances, right? So these EC2 instances should be registered to this load balancer or not? Right. I mean, these EC2 instances also should be registered. So the load balancer, which are all the targets are available. We can say they're all the targets. Which targets it has to be routed. And these are targets, health checkup defining in the load balancer. So important points, listener configuration, targets configuration, and these are targets related health configuration within the load balancer. On the base of the health with these targets, it is going to identify which instances are available, which instances are not available. On the base of availability, to the one of the instance, it is going to route the request. So that is the main understanding of the load balancer. And this is a managed service from AWS. Just define it, these configuration, listener, backend targets, and with health configurations, health monitoring configurations. That's all. Who is going to take care, or who is managing about this one? That is AWS team. Yeah, load balancers are the servers that forward internet traffic to multiple servers, EC2 instances downstream. There is a backend targets. Remember that a target group. This is a target group. Maybe in that group I have that 1 instance or 2 instances or 5 instances or 100 instances. Yeah, why do we need to use a load balancer? Already we are getting these points. Yes, spread the load across multiple downstream instances. Yes, you can spread that load across to multiple instances and expose single point of access. That is a point. One listener to the backend, multiple endpoints where that application is running. One EC2 instance, one endpoint. That means it is going to have its own URL, right? Its IP address with the port. This IP address with the port. This IP address with the port. If you have that 100 instances, 100 endpoints. But all the 100 endpoints you are managing with one entry point. This is an entry point, and this entry point is going to the taking of that routing to that the backend endpoints. So it is going to handle that the failures of the downstream instances. As this instance is down, then it is going to stop that forwarding that the request to the EC2 instance. It uses that other EC2 instances which are in the healthy status. Do regular health checks to your instance. This is important. So keep on checking with that healthy instances and identifying that health insurance is only the making availability in the group and routing that. And providing that SSL termination also. Yes, you can use that SSL based communication to the users level. All the secure communication you can have it. You can configure that HTTP based or HTTPS based. That is a secure based communication for about our websites. And finally, it is enforcing stickiness with the cookies. So what is the stickiness and what about the cookies? We will talk it later. That is one of the important concept in the load balancers whenever we are working with that. So we'll come back to that point as well. Yeah, enforcing that stickiness with the cookies. High availability across the zones. Yes, it is going to high availability across that's multiple zones. Yes, the EC2 instances which are running in the different availability zones, you can configure it. Yes, suppose I have these two EC2 instances in one availability zone and this EC2 instance in another availability zone, then I can use it all these things from the load balancer management. But the scope is the region scope. Within the region, what all the availability zones are available. In that availability zones, you can configure the load balancers. Separate public traffic from private traffic. Yes, backend EC2 instances are going to use the private communications, but this load balancer which will be exposed to that external, this is a public one. Yeah, why use that EC2 load balancers? As we're talking about it, this is a managed load balancer from the AWS team. Because just to define what you need it, the remaining backend management activities, that is upgrading about that load balancers, or as a more load is coming there, because only one, right, active. This is only one active. In case this has got failed, backend if you have that 100 endpoints also all are down, right? So the AWS team is going to take care of that, make sure this is a high availability. High availability is upgrading patches and handling the load and the throughput, everything that is managed by AWS team. So just you need to define that for which request, which target groups you need to route it, and on which health base that you want to check it these instances, health monitoring options, and where these EC2 instances are located, in which availability zones, there is network settings. And this listener is it required HTTP based or HTTPS based listener. So these are all some inputs just defined to the load balancer that is managed by AWS team. Yeah, AWS guarantees that it will be working, and AWS takes care of that upgrades, maintenance, and high availability. And AWS provides few configuration knobs just to configure those knobs as per about our application requirement and ready to go ahead. Yeah, it costs less to set up about your own load balancer. Suppose if you go to that on-premises model, says we can take it, yes, like a big IP F5, a Cisco load balancers. We have the different load balancers which are available in the market. So these are all like less to set up about your own load balancer, but it will be a lot more effort from about our end. That means we need to have a separate resource for it who can manage it about those load balancers, configuring and all the things. Separate administration team is required. 24/7 support required. You need to buy the hardware resources, that is paying the license cost for it. So there are some challenges, but if you go to that AWS, the ELB, that is a load balancers, then just define the configurations and the remaining story, these things, maintenance, upgrades, high availability, that will be taken care by AWS team. And it is helping not only for the EC2 instance, it is going to helping for other offerings and other services as well as like a backend DynamoDB kind of the services, yes, which you can use it. So not only for the EC2, other services as well. Yeah, so that's about
Any
the points.
latency when we put load balancer?
Sorry, please.
No,
Can you
will it be
repeat?
any latency issue if you put load balancers?
Latency issues, I mean, that definitely we can say that any load balancer you are adding is nothing but that is one more layer. But it is not just that much, but they're all very, I mean, needed components in the process model. In the like request and response process models, they're all the needed components. But we have the different solutions from the AWS team itself on the basis of the performance wise, if you are looking about it, the better optimization. Yes, we have the types of the load balancers. That is on the basis of about our requirement. We can use the different types. I'm coming to that section. Is it clear that point?
Yes, sir. Yes, sir. Maybe types will help.
Yeah. Let me conclude it, maybe types of the load balancer, then you will get that answer for it. Yeah, so let's move into that. Now we understand the importance of the load balancer and yeah, so what are the main the sections we need to remember that whenever you are going to use this load balancer. It means listener configuration, backend target groups configuration, health configurations, and SSL required or not, those configurations. And in which networks, that is about subnets, that is availability zones configuration. There are all 4 or 5 important configuration sections we have. This will come back. But what are the different types of the load balancers are available? Yeah, so AWS is having the 3 kinds of the load balancers. That is a classic load balancer. This is they launched in 2009 and a very old generation. The version 1 will say that no one is using that. But yeah, some use cases we can use it, but they're not recommended. But the latest generations which are available, that is V2 version, application load balancer ALB, which they have launched in the 2016. And another type of the load balancer, network load balancer. That is another, I mean, this is also latest generation and which they have launched in the 2017. Yeah, overall, it is recommended to use the newer or V2 generation load balancers as they provide more features. Yeah, app load balancer or network load balancers are the recommended to use it instead of that classic load balancer. And whenever we are setting up the load balancer, one more point, we can define that internal network point of view, the load balancers. Suppose we have that internal application only within the premises should be accessed. Then you can define that the load balancer with that application as an internal. Now only within that network you can access, not outside of the network. But if you like to give that the application to that external, that is a public, then we can define that whenever we are creating a load balancer, we can define that is it internet based or is it internal network point. That means only within that VPC network it works, not outside of it. But in which context we use it is whenever you are setting up that any clusters internally. So then we can use it about that, which will come back to. Yeah, health checks is another important configuration as we are talking about it. Because if the health checks are not configured properly, sometimes identifying that the failure instances from the load balancer before routing, some challenges, right? Yeah, health checks are the important configuration. Yeah, backend EC2 instance, if you're defining that with the load balancer. So on this EC2 instance, let's assume that some port is running with the 4567, some XYZ port. That could be 80 or 8080, whatever the port, doesn't matter that. So from the load balancer, so you need to make sure about it. This port is reachable. Port-based health checkups. Port is nothing but service, right? Apache service. What is the port? 80. Tomcat service. What is the port? 8080. WebLogic service. What is the port? 7001. Like that. So which service is running on this on these EC2 instances, which you are going to configure for this load balancer? So that port-based health checks configuration is important. And not only the port, application route also. So what is this application route? So normally we don't see that multiple applications, but yes. Suppose, okay, let me draw something here. I have this EC2 instance. This is let's talk it about. I'm just talking as a server. So I have the server, and in this server, I'm running about that the Tomcat 1 service. Tomcat on which port? That is, let's assume that it is running on, actually Tomcat port is 8080. Yes, we have launched the EC2 server, and which is where we have installed the Tomcat 8080. But in this Tomcat, I have that users one application, and another one is something reports is another application. So service is the same, but it contains two applications. So if the server receives that with the server IP address port number 8080/users, now this application has to be. So if the request is received to the load balancer, that is /users. So it has to route to this users application, right? And if the load balancer is received that /reports, then it has to route to that reports application on that service. IP address port number is the same. But on the base of that application route path or context path, keyword just try to understand it, route path, this is a route path /users. So what is the URL normally? http://IP address 8080 port number /users. This is one application. Or http://IP address is the same. That is EC2 instance, port number is the same, but the user is going to access the reports application. So if the request is received to the load balancer /users, it has to route to this /users application. And if the application is received the /reports, it has to the /reports. Maybe these users are running in the users and the reports, these two applications are running on the same service, or maybe some EC2 instances which have been handling only for that users application, and another EC2 instances which are handling that only reports application. So on the base of that, how the applications are managing, I mean these two applications are running on the same server, or this application is running on the different instances and this application is running on the different instances. Yes, it has to be managed that routing rules. What we are talking that? Routing rules. So if the users received, which servers it has to be forwarded. And if the reports has been received, to which group of the instances it has to be forwarded. And before forwarding that, so it has to make sure that health of this, okay, port on 8080/users, that is okay or not. If this health is okay, Then route to that, if the request is received the /users, route to this service. Or if the request is received with the /reports, route to this service. Are you clear these points? So what do we call that here? Route-based health configurations. So is it clear? Type that, see if you are good with that. Understanding the word, what I am talking about it, that is route-based, or route path-based rules defining. This is one of the important concepts. So whenever you are configuring the load balancer, can I use it one load balancer for multiple applications? One is users application, second one is reports application. Can I use that same load balancer, or do I need to use that for each application different load balancers? So we can use it that one load balancer, and on the base of the listeners which are receiving path based, then we can map into that if the users receive these instances, the reports receive another group of EC2 instances where that reports application is running. That's we can manage it with the load balancer. So that's we can say that route-based defining the rules, and as well as route or path-based health configurations also important. Before routing that, health checks should be done, right? Yeah, so here if you just understand that health checks, so I'm going to clear this screen. Yeah, health checks, if we just talk it that, health checks are crucial for the load balancers. They enable the load balancer to know, so the instances which are it is forwarding that the traffic are available to reply to the request or not. If I forward to this instance, is it healthy or not, and it is able to take the request and handle the request and give the response back or not, that checking we can say that health checkups. So the health check is done on a port and a route. Yes, that's we are talking that port based and a route based. That is application, whatever you have, slash. Okay, root application slash give that, or slash user slash reports, multiple applications or submodules. So if the response is, whenever it is defined with the port and route path based, if the response is 200, then it thinks that load balancer, this is the healthy, otherwise it is going to mark this one as a unhealthy. And we have the intervals. We can define that the interval says what is the interval that can be used to verify the health of the EC2 instances. Yeah, so this is one more important configuration. There is a health checks, which we use in the port and path, route path. Yeah, first let's understand the difference between classic load balancer, application load balancer, and network load balancer. Okay, now we understand health configuration. But this health configuration on the base of the port and with the path, can I configure it or can I use it in all the load balancers? So that is the next concept. If you come back to that, apply that concept to the load balancers. Yeah, application load balancer, what does it do? That is app load balancer. That's, we'll say that ALB. The backend multiple target groups we can define it as we're talking that. Yes, I have that users application in these EC2 instances which are running. Or I have the reports application in these EC2 instances which is running. So what is the point we are talking here? As application management point of view, we have the different EC2 instances. So these EC2 instances are using the user's application or running on this, and another application like search or reports or whatever it is. So another application, it is running on these EC2 instances. So this one into one group, where that users based one group, and another path that is reports or search based another group of instances. Now two groups we have, right? But now from the user, that means www, if it is received that route based slash user. So now the load balancer has to route to that one of the EC2 instance which is in this group. It should not route to this group, because if it routes to this group, then this user is going to get the message as 404, right? Page cannot be found because you are looking at user application in different EC2 instances, but actually that is available in this EC2 instance. So you need to route to that only this group of instances. And if it is a request is received search or like reports on the basis of that, it has to be routed this group of EC2 instances. So here application load balancer, we can use it. Protocol HTTP or HTTPS. Port, yes, on the EC2 instance, suppose 8080 port or 7001 port, and not only the port and the path based routing also. Three considerations: protocol, port, and path. Path is slash user. Port is Tomcat port 8080 or WebLoy, whatever the service port, 80 or whatever it is. And finally, the protocol is HTTP or HTTPS. So these are 3 points that we can consider, and we can define that request on the basis of the request to which target group it can be routed. So this is the support from the application load balancer. Yeah, now if we just consider about it, the points from the application load balancer, we can say that layer 7. What is this? Layer 7. So if you know that the OSI layered architecture, yeah, OSI model 7 layers. So if you go to the images, that would be better. Let me go to the images. Let me use this. So if you'd like to understand the difference between app load balancer and network load balancer, so how they have designed backend is, these are all the protocols they are using that. So if you, now application load balancer is helping on the protocol HTTP, HTTPS port, you can use it, and path also we can use it, slash users based routing or slash reports based routing. That means path based routing rules we can define it. That means backend it is going to use it 7 layered architecture. Application load balancer uses the OSI 7 layer architecture. What is this OSI? That model says any data you are transferring over the network. Now suppose in the browser I have entered some text. That is application. You are using HTTP or FTP, there are the protocols. You are entering some data, end user. But how the data will be transferred over the network? Directly the data which will be forwarded? No. It is going to use it, all these layers, converting into the physical structure, which can be used on the wireless or the fiber, coax. They're all like Normally we can say the 0-1 representation of the packets data. The packets, frames, yeah, they having the connection, end-to-end connection with the TCP, UDP. That means high level we are using HTTP, but background it is going to have the dependence on the TCP or UDP protocols. But if I use the TCP protocol directly, my data I'm interacting here, and data conversion time is very fast, right? Whenever I'm transmitting the data to the server, so if I use the TCP or UDP protocols, my data converting from that end user data to the physical structure of the network, it is very fast because it uses the only 4 layer. But if you are using the HTTP protocol, that means we are using all the HTTP based protocol requests. But background, before submitting the data over the network, application to presentation, then session, then transport, then network, then data link, then finally the physical. So the data conversion, it is a 7-layer architecture. So if you need more information, you can just refer it. But yes, if you'd like to understand the difference between the app load balancer and network load balancer, first we are talking about app load balancer from the AWS. They have given on the base of the protocol, you can use the HTTP or HTTPS based protocol with route based rules, which uses the 7-layer architecture of the OSI model. Is it clear that point?
So 7-layer architecture means so how it will be differentiated? So based on road, host name like that, or
Yeah, like a host name. Yeah, host name. If you just talk it, that is internal layers. But this is the main key point. Just remember that protocol, HTTP, port, that is service, and third option also, that is a path based. The path based, which we can say that is about suppose slash reports or slash users we are talking about. So it can handle that. The HTTP layer can handle that. But TCP layer, if you use it, it doesn't understand all those points. So transport layer, I can use it only protocol and port number, but I cannot define that path-based routing rules. Path-based, if you like to go ahead, you need to use it 7-layer architecture. So which supports HTTP, FTP, these are all the protocols, and then it converts into that syntax layers. Then session, it is going to creating that is a sockets level. Then it uses that's a transmitted protocols. Then that data, whatever we have submitted, converted into the packets and the frames. And finally, the physical structure with that either wireless or wire-based approaches. So the data conversion, which one is the fast? Is it a 7-layer architecture is the fast or 4-layer architecture is the fast?
7 layers.
Performance wise, which one will be fast?
Faster is
network?
Yeah, performance wise, yes, transport layer is this is fast, right? Comparing with that 7-layer, converting these 7 layers, it takes some fraction of milliseconds additional effort. But if I use it that 4-layer architecture, that is just defining the protocol and with the port number. So my data, but I cannot define the path-based routing rules if I'm going to use it the TCP or UDP. But I can define that socket-based, that is a port-based mechanisms. So this is somewhat very fast compared with that 7-layer architecture. Yeah, so if you just talk it app load balancer, background, what is the OS layer it is going to use it is 7-layer architecture, where we can define the protocol, port, and the path-based routing rules, it is supporting that. So my application, I have the multiple applications and with the backend endpoints, that is EC2 instances. But I need to use the one load balancer on the basis of the path-based routing rules. If I would like to define it, which type of the load balancer I need to use it? Application load balancer, we need to use it. But application load balancer we are using is nothing but internally it is going to use the layer 7 allow to do load balancing to multiple HTTP applications across machines, multiple target groups. Load balancing to multiple applications on the same machine also. Yes, as we are talking this in the first example, I have the 8080 service with users application and as well as reports application in the same EC2 instance. That's also I can define it. My EC2 instance is same, but path. Yeah, multiple HTTP application across multiple machines or multiple applications on the same machine or load balancing based on the route in URL. This is important. Application load balancer, when do we use it is route-based rules to define it. Hostname based in URL also. Yeah, basically they are awesome for the microservices and container-based application, example like Docker, Amazon ECS. Yeah, so this kind of application, if you have that, or as simplest is multiple applications on the base of across machines with the path-based routing rules, then app load balancer is recommended. Yeah, it is having a port mapping feature to redirect to a dynamic port. Yes, port mapping also. In comparison, we would need to create one classic load balancer per application before that was very expensive and inefficient. What this point is, we were talking this V1 generation of load balancer, right? Suppose if I may have the two applications, suppose if I'm having like this users one application in one, in some of the EC2 instances and a set application in another EC2 instances. If it is the V1 classic, the load balancer, I need to use the two load balancers for this. So one application, one separate load balancer. If I'm having the 10 applications, 10 load balancers, I need to use it that in the classic. That's why it is not recommended. V1 is not recommended. Because if you have the 10 application, 10 load balancers. But application load balancer, with route based, if I'm having, that is a path based routing rules to define it, then we can use it app load balancer. If the request comes with /user says route to this group, or if the request comes to that /reports or a /edge, route to that another group of that. If you have this kind of the requirement, app load balancer is recommended, but it is a little bit performance impact. Definitely as a 7-layer architecture internally, which uses that data transfer. Yeah, application load balancer, good to know some points. So here, client IP, whatever we are receiving that request which will be received to the load balancer, but from the load balancer, the EC2 instance. That means always the EC2 instance is going to looking that only load balancer IP, right? So EC2 instance doesn't know about the client IP. Yeah, so this is one point. The client IP that is receivable up to that, the load balancer. But EC2 instance, if you would like to get that the client IP, then from here we need to use it some headers reading. Yes, in that request headers concept is available. So application team, they need to use the request headers to read that client IP address which is received, but EC2 instance directly cannot see the client IP. Yeah, whenever we are configuring that application load balancer, one more important point is stickiness can be enabled at the target group level. Yes, at the target group level, we can enable the stickiness. What is the stickiness? Suppose if I go to this example, 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 if I go to this ex So what we are talking that here it is default behavior once if you define the load balancer with the backend target groups. So user one, suppose I am the user one, which I have submitted my request. My request first it will be submitted to that EC2 instance one, let's assume that. And EC2 one is processed and it is given the response back and I got the response to my browser. Then again I submitted one more request. That means subsequent request from the same user. The point here it is one request. Second request also I submitted. But second request, which instance? Is the EC2 instance 1 or EC2 instance 2? Default behavior that uses the round robin algorithm. So even the subsequent user also, subsequent request from the same user also, it will be routed to that different EC2 instance in the group. But what is the disadvantage here? Same user, first time this instance, second request this instance, third request this instance, it using that, if you just think of it, so it has to manage the client session, right? Client session, client state while processing the request. Suppose I have logged into the riseandshine.technologies.com and I'm accessing the courses. First I click on the course. What are the courses which I'm registered? So it is loading from that. Okay, it is loaded. But again, I'm clicking on the particular course. Then if it is routed to the second instance, again, that course is catalog and everything, it has to load that data, right? The session data has to be managed here. Before it was in this instance, now it is in this instance. It takes some additional the latency to load the data of that the user session and processing the request and giving the response back, right? Already this user, this EC2 instance level first request was done. And second request, it is routing to the second instance. And again, it is loading that the same session data as a default behavior. So to overcome those latency issues in the application load balancer on the target group, what we can do, that is we can enable the stickiness. That is to improve that somewhat performance of the user's request and responses. Same subsequent request and responses. Here we are talking that. Yeah, to improve that application users, the request and responses subsequent, we can enable that stickiness at the target group level. This is not at load balancer. This property is available at target group level. Same request go to the same instance. That saves a lot of time loading that user session data. Stickiness is directly generated by the ALB, not the application. Yes, ALB is going to helping that to generate the sticky session. That is a cookie, and the same cookie that will be used in the request and response. And whenever the load balancer is received the stickiness information, yes, which instance contains that stickiness to the same instance that request will be routed. Yeah, so that is one more the configuration. All these things we'll see that the practically. But first understand the concepts of the load balancers, how they have come up by the AWS team. Whatever we are talking that, it is all AWS team. They have given the service for us. Whenever you are going to use it on the basis of about our application requirement and the performance point of view, the client sessions point of view, backend applications point of view, which can be used with as types of load balancers. But we are talking about the first application load balancer. Classic load balancer, leave it that. So one application, one load balancer. But app and network load balancers, yes, if you have the multiple applications also on the basis of protocol and port number and route options, you can decide that the load balancer. So that is app or network. Yeah, application load balancer supports HTTP, HTTPS protocols and WebSockets protocols. The application servers don't see the IP of the client directly. As we're talking about it, app server, it doesn't see directly the client IP, because that the connection will be terminated here, and the request which will be the privately internally connected to the EC2 instance by the load balancer. The true IP of the client is inserted in the header as we are talking about it. The developer who is implementing the application on the EC2 instance. So if he wants the client IP to display in that application, or if you'd like to use that in the application, or if you'd like to log that information, then he has to read from the headers, the request which is receiving from the load balancer. This is the header field, X forwarded for. If he's going to use this, read this header from that, the request object, then EC2 instance level, you can get it to this client IP. So we can get port also, X forwarded port, and protocol also, X forwarded protocol. So there are some header fields which are providing by that the load balancer to understand about client request at application level. Protocol, port number, and IP address of the client. This is anyway, that's the application team, they use it. We don't need to worry about it, but just understand the concepts of it. The EC2 instances doesn't get directly the client IPs. So client IPs, the connection which will be terminated here, and yes, it is going to use the load balance private IP internally to connect it to the EC2 instance. Are you clear about this application load balancer? And if you are clear, just type that ALB in the chat window. Now we'll differentiate with the network load balancer, and we will come back to that. That is network load balancer. Okay, so we got it clear. I was expecting ALB. Fine. Okay, no issues. So application, that's about a application load balancer. Important points, remember that. Remaining, almost all the configurations are the same. But here, additional thing what we are trying to understand is route-based rules defining and stickiness. Route-based and stickiness. There are the additional things compared with the network load balancer. Yeah, if you try to understand the network load balancer, here also the same concept. But this is going to use the TCP or UDP based protocol. So the routing rules, whenever you are defining that to the backend target groups, we will use the TCP based routing rules. And here there is no concept of the route based rules. You can define that the only TCP, that is the TCP protocol with port number based routing rules, but you cannot use it path. So if the port is receiving that with some specific yes, route to this target group, or if the port is receiving that to this yes, route to this target group, like that we can define on the protocols level and sockets level, but you cannot define the path based routing rules. That is the main difference. That's why we say that this is the 4-layer architecture. The 4th layer we have the TCP UDP, right? So directly it starts from that layer. But if you're going to use the app load balancer, you have the user level also. That is route-based rules also you can have with that. So that is the main difference. Network load balancer. This is especially which they use it for the gaming applications or the video streaming based applications. Suppose HTTP based protocol, if I'm going to use it, that the business transaction that will be used mostly. the business transactions where we should not lose that even one packet of the data also. But video streaming application, suppose whenever you are accessing the Netflix, but because of some network, some packets we have lost it on the network. But we don't see any issue, right? Maybe some pixel, the image, maybe sometimes, that is going to have it some the picture doesn't see properly, where you will see there's some small boxes like that. But we don't see that impact if the packet is lost over the network also. But streaming the data, it should be very fast, right? Yeah, gaming applications are, if we just talk an example, is video streaming based applications, which are required high throughput of the data, the transmitting. Then we can go ahead and using about it network load balancers. But a transaction based applications and the packets which we should not lose it, then we use it about app based load balancers. But those are all somewhat performance less, but reliability is more compared with the network load balancer. Reliability of the data transmission is the more on app load balancer. But here the performance will be improved because there is no rules on the 7th layer verifying that only the 4th layer, that socket level rules verification, which is the 4 times better performance than the app load balancer. 4 times. But the reliability on the data, that's we need to think it of it. Yeah, if you conclude that the network load balancer, it uses that layer for forward TCP traffic to your EC2 instances. Handle millions of the requests per second. Yes, high throughput or high load you are expecting about it, this is recommended. Support for the static IP or elastic IP. Yes, you need to have it. Static IP or elastic IP for it. And less latency. Yes, compare with the app load balancer, this is the less latency. That is which is going to take it 400 milliseconds for ALB, but here it is going to take it only 100 milliseconds of the time to handle the request. So performance and if you think it about that TCP based traffic routing rules, then recommended is a network load balancer. But if you are looking about that, the protocol with the port and route based routing rules, and with the reliability, then recommended is app load balancer. But app load balancer is somewhat performance wise the latency issues. Yeah, network load balancer are mostly used for that extreme performance and should not be to the default load balancer you choose it. The overall the creation process is the same as application load balancer or network load balancer. Yes, so using that or whenever we are working that as a cloud engineer, working on the app or network load balancer, we don't see the difference, the configurations point of view. But yes, network load balancer, we use the TCP protocol, and app load balancer, which we use is that HTTP based protocol routing rules. So that is the difference. Other than that, remaining story is the same. Now, are you clear about that? ALB and NLB?
Clear, sir.
Type this in the chat window, ALB and NLB. Application load balancer and a network load balancer. A total ELB will say that elastic load balancer. Elastic load balancer is having 3 types. Classic load balancer, leave it that no one is using that. But we do the latest generations app or net. App is more transaction based HTTP protocol. If you like to define it, use it. But if you have the TCP based routing rules and high performance and video streaming, these kind of applications, then we can go ahead think of that NLB.
It depends upon the application, we can
Yes.
choose ALB.
Yes, exactly. application and application routing rules that will be decided that which type of the load balancer. Yeah, classic load balancers are the deprecated, and application load balancers for the HTTP, HTTPS and WebSocket, and network load balancers for the TCP. And the CLB and ALB support SSL certificates. Okay, both are supporting SSL based communications. And all load balancers have health check capability. And ALB can route on based on the host name or path based. Yeah, that is a host name and path based routing rules we can define. ALB is a great fit for the Docker. That means on the same machine, multiple ports are running, or ports and path based routing rules. Then you can use the ALB. Yeah, so that's about understanding the points. Anyway, we'll conclude this one later. Good to know the solve these points. Yeah, now let's go ahead and where do we have that option to talk it about the load balancers in console? Amazon Management Console. Let's go ahead. So let me log into the console. Okay, let me use it. Authentication failed. Okay, recently I changed the password, right? Good. Yeah, so I'm in the Mumbai region. So there could be any region. To make sure that which region you would like to create it. And go to the EC2. And let's talk it about the load balancers. Yes, here you can see that's in the load balancing concept in the EC2. Load balancers and target groups. Target groups we are talking is nothing. There is a backend endpoints. Backend endpoints are nothing but about our EC2 instances which are required. We will group it. And this target group we will attach to the load balancer. Yeah, so let's go ahead and the first you can create a target group. Then you can come back to the load balancers, or you can, while creating the load balancers itself, we can create a target group. Okay, let me go ahead directly to the load balancers. Yeah, so here we can see that create load balancer option. And while creating a load balancer, do you want to create, compare the load balancer types? Yes, they have given that option to check it, comparison of the load balancer types also. So app load balancer or network load balancer or classic load balancer. And recently they have given the gateway, that is a proxy kind of the load balancer also they have given. But yes, so let me go ahead and yes, let's compare the first. Yes, compare and select the load balancer types. Yes, application load balancer, as we are talking about it, HTTP or HTTPS based protocols you can use it, and you can map into the backend target groups. And here I don't see there's any networking dependency. So they're all running on user level protocols, browser level protocols. But network load balancer within the particular network, the VPC, and where you have the TCP or UDP based routing rules to manage it. So using these protocols, if you would like to map into the backend target points, then you can use it that. the network load balancer. Even you can see that from that VPC internal TCP protocol, you can map it to that another load balancer. Yeah, the request receiving through the network load balancer on this TCP and routing to that the backend ALB. But this is, I mean, more layers. If you increase it, performance will be degraded, right? In the request and response process model, if you minimize that the layers, then performance will be good. But if you're adding the more layers, then the network dependencies and service dependencies, definitely it is going to have the impact on the request and response, the lifecycle time. Yeah, gateway load balancer. This is kind of the proxy kind of the load balancer which they have given that. So you can just refer it. I showed that much. And classic load balancer, there is a previous one. So this is also like as you see, I mean ALB, but only one target group you can map into that. Multiple target groups you cannot use it. But it supports HTTP, HTTPS, TCP, and SSL based communication. You can use it. But target group only one. But here you can define the multiple target groups. Yeah, you just refer that the documentation if you need that more. And let me show that the application load balancer or any network also that's almost the same, but protocol is different. But yes, let's go ahead understanding that the more routing path based how to define it in the app load balancer. Yeah, so give the name. This is I'm going to use it web server load balancer. Some name for it. Let me give the full name. Web server load balancer. As we're talking that, do you want to run this load balancer only within the network or outside of the network? That is a public. Yes, internet facing or internal. Internal load balancer also requested from the clients to targets using private IP addresses. But internet facing, this is load balance request from the clients over the internet. That is any IP address. And this should be launched in the public subnet. Yeah, let's go ahead with internet facing. And which IP address types do you want to support? Yes, IPv4. Or if you need to, I mean, if you are running about it, the backend targets with the IPv6 also, then you can use it a dual stack. That means IPv4 and IPv6 address it supports. But if you have this only IPv4 for that internal load balancers, then you can use it that IPv4. This is recommended for internal load balancers. But external, which are coming just either with IPv4 or IPv6, you can use a dual stack. And as we are talking that the network mapping, that means which availability zones that do you want to use it this load balancer. Suppose we are planning that the backend target group EC2 instances in the multi-availability zone 1A and 1B. Then you need to define networking mapping here to that 1A and 1B. Yeah, so here you can see that the VPC, yes, in which VPC is by default now current default VPC which is available, and which availability zones that we want to have it. So which we have selected the Mumbai region. In the Mumbai region, it is showing about it 2 availability zones. But if you go to the other regions, maybe you will find it more availability zones. But as we're talking that the high availability, at least 2 or more availability zones, we need to select it, right? Yes, where you are planning to launch about your EC2 instances, those availability zones, you can select it. So this is network mapping. As we're talking that launching load balancer with high availability. Scalability, we are not talking here. We are talking that the only high availability. Scalability will come back. That is an auto scaling. But scalability on the load balancer that is providing by AWS team itself, right? If the load is increasing, that is handling by the AWS team itself. Scalability, we don't need to define explicitly for the load balancer, but high availability, if we just talk it that, the backend target groups, yes, in which network those are available, that network is a span on that which availability zones, that is AP South 1A and 1B, as we have chosen that this region. But I am having the EC2 instances only in 1A, then you can use it at only 1A. But if you have only 1A, that means one data center. But if this data center is having some maintenance activities, then about your application will be shut down. Yeah, so at least 2 data centers that is recommended. And finally, the security group. So we are defining that this load balancer, yeah, either network or app load balancer, whatever it is. So before entering into this load balancer, the security group here, security group. We know it like security group at EC2 instance level, but now we are talking about it. Who can or which request does do you want to allow that to access this load balancer? But this load balancer, we are defining that internet is nothing but anyone, right? That means in the security group, we need to define that any IP address mapping to this load balancer. And between the load balancer and to this EC2 instances target group, that is also we need to define it. This is a target group level. So total 2 security groups. One is at EC2 instance level, security groups. Second one is security group at load balance level. So this one which we are talking that the security group at load balancer. Yeah, so application load balance requires at least one security group. Yes, you can choose that already existing security groups if you have, or you can create a new security group and you can attach that security group. Yes, let me define the security group now. This is a load balancer security group, right? ALB security group. You can define some description. And inbound rules, I would like to add it. Anyone can access the load balancer. Anyone is nothing but IP addresses. Any IP address. Okay. But which port? This is the load balancer port. Load balancer by default on which port it is listening 80. So anyone who is asking about it, the load balancer port that is 80, we are going to allow that. Outbound rules anyway, that is defined that. And let's create the security group. So this is a security group which I'm having. Now let me go ahead and let's refresh here. So let's find that security group. This is the one, right? ALB security. So we have defined anyone can access that to, this load balancer on the port 80. Yes, now we are defining that. Okay, we are defining here the security group 80 enabling that. But 80, you need to define for this load balancer, right? So load balancer, now this side we are talking that. The listener side. A load balancer we are conferring always 2 points. One is target group. Target group separate section. But load balancer we are defining is nothing but is what are the options we have defined? Is it internal do you want to use it or external do you want to use it? Do you want to support that IPv4 support or IPv6 also? Dual stack do you want to use it to supporting that or only IPv4? That's we are defining that. Then security group we have defined. That means any requests which are coming that on the port 80 we are allowing to this load balancer. Because this is as a public anyway, public any IP address. Or if you have this only specific VPC CADR, that CADR you can define in the security group. So all the points on networks we are defining that. Networks, yes. Which availability zones? Now maybe the instances which are running either AP South 1A, 1B, we have defined this load balancer can be routed to the networks either AP South 1A or 1B. The instances which are running either data center 1 or data center 2. That's we have defined in the network settings section. Now this load balancer can identify the EC2 instances which are running in AP South 1A or 1B. Listeners. Listener is nothing but entry point. And which port do you want to access this listener? 80. If it is the HTTP protocol. Or if you like to define the secure listener, then you can choose that HTTPS, that is 443. If you are using that HTTPS, then you need to configure this in the security group allowing that 443 also. That means anyone is accessing that HTTPS colon that load balancer URL, then it uses this listener. Or HTTP with the port, and you can change this port also. Suppose I would like to access this load balancer only on the 81. Then security group level, I need to change that 81. Anyone is accessing that. That is the meaning of this one. But anyone who is accessing this on this HTTP with the port number 81 or 80 or 443, that is security or non-security, then you need to forward the request to the backend target group, right? Yes, if anyone is accessing that to this load balancer on the port 80 with HTTP or HTTPS with the 443, we would like to forward the request to the backend target group. That target group we need to configure it here. Yes, if you already created the target group, as we're talking that you can create a target group and you can come back here. Or now also you can create a target group. Create a target group. So now what I'm defining that if any request which is coming to this load balancer on the protocol HTTP. So here as we are talking about it, ALB supports HTTP and HTTPS based listeners. The port is about our custom port. That is about your choice. And which group do you want to route it. Now you can create a target group and you can assign that. So you can add it multiple listeners. Suppose I'm receiving this request on 80, route to this target group. I'm receiving that the request on 81. Yes, I can route to that another target group. Or I'm receiving this on the HTTP port. Yes, I can route to that another target group. Yes, this is a ALB supports multiple listeners. We can define it. Multiple listeners we can define it, and we can map into the backend target groups. And load balancer tags, and finally the review about it. But here we didn't create any target group. Target group is important, right? Otherwise, how it is knowing that?
Here we have only two type of protocol, HTTP and HTTPS.
Yes, correct. Because as we are talking that ALB supports HTTP or HTTPS protocols.
Okay, based on the load balancer type, it is showing the protocols.
Yes, exactly. If you go for that NLB, then it shows the TCP or UDP based protocol. As we are talking that app layers which have been defined. So ALB based HTTP, HTTPS listeners, you can define it. And if you go for that NLB, you see that this is app load balancer, which you can see that HTTP based. Or if you go to the NLB, it shows that a TCP protocol. Are you clear about this?
Yeah, yes, sir.
Okay. Good. Now, these are all like whatever we are talking that this side, I mean the listener side. That means load balancer side. Giving the name, is it internal D1 to access, external D1 to access, D1 to support this one IPv4 only or IPv4 and VP6. and which availability zones that you want to map it. This is important. Suppose backend target groups are running in 1A and 1B, but here load balance you define that's only 1A. That means it always connects to data center 1 only, 1A only. But even the EC2 instances are running in the 1B, then it cannot find it those EC2 instances. So on the base of the target groups where those are running that, you need to define about your load balancer. And the security group, yes, this is the entry point, who can access that, on which port they can access it. That's you can control it for this load balancer. And the listener, yes, HTTP or HTTPS based. So target group is important. That target group, already time is running, right? We'll see this practically tomorrow on the target group creation and attaching to this load balancer. Then the working with that, creating a load balancer and checking that. Today, we just understanding that the properties of the load balancer creation. But tomorrow we'll talk about the target groups. And once these target groups have been created, how do we attach to the load balancer? So today this section we understood that. What are the important properties we have? Is it internal facing or external facing? And is it supporting that which listeners, like which protocols? Yes, HTTP do you want to use it, or HTTPS based do you want to use it? If you're going to use the particular ports, yes, enable the security group. Which is area that's do you want to allow that? And which the availability zone that do you want to support it? So these are all the things that's listener side we have defined if you just clearly understand the load balance. And the networking settings. But tomorrow what do we do? That is, we go further to defining the target group. But these target group, the EC2 instances, first we'll see that the manually, then we'll come back with another feature, auto scaling group. That is a horizontal scaling features applying. But first, yes, tomorrow we'll launch this with normal, the manually. We'll create two EC2 instances in the two different availability zones, and we will define it as a target group. And those that target group will attach to this load balancer, and we'll test it through the flow. And we'll observe that what is the session stickiness and the health check properties. How do you define it? Those are all some other configurations. We'll look into that on the target group level. Then we'll see this complete the flow, the execution. Are you clear these points? Type that C or CLR if you are good with that, these concepts, or let me know if you have any queries or questions. Tomorrow practically we'll see that this load balancer. Interesting, right? The concept.
So Srinivas has posted a query that what is hardware and software load balancer. I think hardware load balancer is a physical server, right? And
Yes.
software load balancer is just a layer as a service.
Yeah. Okay. So I didn't see this message. Actually, it was off. Okay. I heard from the admins there is software and hardware load balancer. That is, I heard on premises environments. Yes. So now you can talk it this load balancer, whatever we are taking from the AWS team. It is kind of the hardware load balancer. Simple. But software load balancer, that is a service based, how do you configure it? That is a proxy services, how do you configure it? I will talk it whenever we start the DevOps. That is about our own, the service management. But this is from that AWS team, we are taking that. Just think it, this one is hardware load balancer, you are taking that from the AWS team. But software load balancer, as administrators, we need to manage that and we need to configure routing to the backend app services. So that means after this external load balancer, we receive to that web layer to that app layer will forward it. that web layer to that app layer, that is a web server, how do we configure as a proxy server with reverse proxies? That's we'll see the demonstration in our 3-tier architecture of application in DevOps. Did you get my point? Yeah, good. Yeah, anything I missed it in above questions because I didn't open the chart window. That's why I didn't see these messages. Fine, good. Okay, so that's all from my side for today. Understanding that these important load balancers, and we will meet tomorrow and we'll see this practically with the backend and target groups manually adding the EC2 instances first. Once this load balancer is understood, then we go to that understanding about with auto scaling group, how to manage in the target group. Load balancer configuration always the same, but in the target group, first we are talking about the manually launching these EC2 instances. But later, with the scalability feature on the base of the current load, how do we handle that? The adding new instances to the groupies in the auto scaling group, we'll talk. Yeah, so that's all. So I hope so it's clear, right, everyone?
Clear, sir.
Good. Yeah, thanks. That's all from my side for today. I'm going to log off and we'll meet tomorrow and we'll continue with the demonstration. Thank you all.